All right, for homework 919, it might be a long one, but this is really important for the entire module 2. I'm going to have you check all the work and make sure you have all the work that I show you on your packet that I gave you today. And for my honors classes, I have some extra problems at the end I'd like you to try. They're open to anybody to try. And then I want you to write down the 6 words to let me know that you listened. So again, on your packet, copy all the work I'm going to show you. Write down the 6 magic words to show me that you listen. And then for my honors classes, do the 2 extra problems I'm having you do, which of course are open to anybody to try. So here we go. For these, I want you to realize these are positive slopes going left to right, going up. This one is definitely a steeper line than that. I could use my eyeball just to see that it is steeper. So that one is the greater rate of change, but make sure you're writing all the terms I'd like you to. That is linear. It's a straight line. Continuous, because it's a line going through them, all the points. And if I had to write an equation, that would be one of those explicit form function equations. And that is f of x equals d times x plus the f of 0 term. Cannot forget that. Need to remember that. So more steep. These, I could see with my eyeball that this set of data is going down, but this set is going down at a steeper rate. So this set is the greater rate of change. And of course those are dots. It's still linear, but that and those dots patterns makes it discrete. If I had to write an equation for that one, that would be a recursive form equation. And of course that is f of x equals f of x minus 1 plus d. But in this case, since I'm going down, I'm going to write it f of x minus 1 minus d. That would be the form for that equation right there. Okay, the next problem. These ones are a little bit more detailed because you need to be able to find your rise and run. I want to see that. The first word is explicit. Explicit is the first word. All right, for these, I want you to connect any 2 points on that line with a run and a rise little triangle connection here. So I'm going right 3, up 2. If I put those 2 numbers together for my slope, that would be a run of 3, a rise of 2, or a slope of 2/3. If you want to change that to a decimal, type in the 2 first, divided by 3. That will give you 0.6 repeating. This one, going from this dot until I could go straight up over 4, up 3. And again, that slope is 3 over 4. And that written as a decimal is 0.75. And you can see that 0.75 is slightly more than 0.6. It is slightly steeper. And again, all the labels I want you to write for full credit and all this work too. That is linear, continuous. That would be an explicit equation. Alright, these two with negative slope, I could see that I'm going right to and then straight down to the first point I see, down 3. So if I write that in slope-intercept form, I'm going to make sure I put that negative 3, that's my rise on top, over 2. And that reduced down gives me negative 1.5. If I divided negative 3 divided by 2, it would give me negative 1.5. My other graph, to connect these 2 points, I'm going right 3, down 3. If I write that the correct way, it's going to be negative 3 over 3. And that reduces to negative 1. And you can see negative 1.5 is steeper, is going down faster. Going over one box, but going down 1.5 versus going over one box and down one, this is steeper. And of course that is linear, continuous because the line is going through them. And if I had to write that form of an equation, it would be explicit, an explicit equation. All right. The next problem, here we go. All right, for these table ones, if there's no units, just find the slope and compare them right away. This is going up by 8 versus this table over here going up by 2. That slope would be the change in y over the change in x. That would be 8 over 2. This one is going up by 6. I will fix that. Going up by 6, going up by 6. This is going up by 2. If I put those together, one slope is 6 over 2. The other one is 8 over 2. 6 over 2 gives me 3. And then the other one, 8 over 2, gives me 4. So again, the slope of 3 is not quite as steep as a slope of 4. So that is a, there we go. So 8 over 2 gives me a slope of 4. So I can see this second table has a greater rate of change. And then for this table, all I could tell is that it's linear. The second word is continuous. Continuous is the second word. All right, next tables. This first one is going up by 4. We're on the x-axis going up by 2. This one is going up by 3. And the y-axis is going up by 6. If I divide that out, that would give me 4 over 2 for this one, which has a slope of 2. And then this one's 6 divided by 3. Also gives me a slope of 2. So don't write a 3 right there. That is a 2. These are equal. So again, make that a 2 right there. These are equal. Neither of them is bigger. So I made a mistake of making that 3, but make that 2 right there. All right, for the next one. And again, I mistakenly circled that one. That is not true. These are both equal. All right, next table. These ones going down by a half, timesing by a half, timesing by a half. We're on the right, timesing by 1/4. This lets me know these are geometric, so I'm not going to try to find my slope. I'm just going to focus on the fact that these are being times by a half. These are being times by a 1/4. That is a greater rate of change. These are exponential. So again, 1/2 is a greater rate of change than 1/4. 1/2 is 0.25. 1/2 is 0.5. 1/4 is 0.25. This one a greater rate of change, exponential. But again, fix this. This one, these are equal. They both have a slope of 2. All right, almost done. Next problems. These, again, for just equations, just focus on the number in front of x. The bigger the number in front of x for these explicit forms, the greater the rate of change. These are both linear. These are continuous, and they are an explicit form already. Make sure you're writing that. The next one, the -4 is going steeper than -2. Going over 1 down 4 versus over 1 down 2 will get you steeper. So this one has a greater rate of change. It is linear, and it is continuous because these are explicit forms. For our geometrics, look at the number in the r spot, the number that's being raised to the x power. That tells you what is the greater rate of change on just equations. This 4 is bigger than that 2. That makes this a greater rate of change. These are exponential, and these are explicit forms, so continuous. Make sure you're writing all these words. All right, next set. For these recursive ones, look at the plain number. If that's bigger, a greater rate of change. These are linear. Because these are recursive forms, they are discrete. All right, next problem. These recursive ones for geometrics, timesing by 1/4 is more than timesing by 1/5. 1/4 is 0.25, where 1/5 is only 0.2. A greater rate of change. And of course, this is exponential because I'm timesing, not linear. And these are discrete because they are the recursive pattern right there. All right, these bottom two. I have a slope of 3, where this one has a slope of 5. Even though that's recursive pattern, if I was to write this in explicit form, it would be 5x. But again, know that that number is the same as the slope. This is bigger, greater rate of change. Linear and discrete for this one. Where over here, this is linear, but continuous because it's a explicit form. Linear, continuous. But this one still has a greater rate of change. All right, almost done. For this one, going up by 60 right here, going up by 2 on the side, but be careful, these are different units, so I'm going to have to do a conversion. So this slope is 60 miles for every 2 hours. If I reduce that down, that gives me 30 miles for every 1 hour. Got to be careful on the next one though. This is going up by 2 and the miles is going up by 3. And it looks like at first it's not as fast, but then you got to do the conversion to really see. So this one gives me a slope of 2 miles for every 3 minutes. And again, doing my conversion, if I take that 2 miles over 3 minutes and I times that by my conversion, which is 60 minutes for every hour, again 60 minutes over 1 hour, and I times that straight across, my minutes units are going to cancel. That's going to leave me 2 times 60 over 3. That gives me 120 over 3. 120 miles over 3 in the hour unit left on the bottom. And that gives me 40 miles per hour for every 1 hour. And sorry, my pen's running out of juice there a little bit. So I can see that 40 miles for every 1 hour is more than 30 miles for every 1 hour, a greater rate of change. These are linear tables. I don't know if they're discrete or continuous. All right, next problem here. I want you to go from inches, 4 inches right here for every 3 minutes. I want you to be able to write that as slope. So that would be 4 inches for every 3 minutes. And I'm going to change that from inches to hours. This one, 70 inches for every 1 hour. So if I wrote this as a slope, that would be 70 inches per hour. 70 inches for every 1 hour. So I need to make this a unit where I could compare it. So I'm going to change this and times it by the conversion 60 minutes for every 1 hour. I'm going to multiply straight across. The third word is discrete. Discrete. And that multiplying straight across, minute units cancel. And that leaves me 240 inches for every 3 hours. So 240 inches for 3 hours. And multiply straight across, minute units cancel. That gives me 80 inches per hour. So I could see a little bit more than 70 inches per hour. 80 inches per hour. That makes that change.
And of course, that one and the other one, they are both linear. All right, the last word for the Math 1 students is arithmetic. Arithmetic. At this point, Math 1, you are done. For my honors classes, I have 2 extra problems for you to do with 2 extra words to write down. These are open to anybody, of course, but my honors kids, I'm grading you on doing these. All right, so I'm going to go back to the graphing one. I'm going to shrink that down. We're going to look at this problem right here. Again, where this is a graph where it's going a y-intercept of 10 and then going over 1, 2, 3, 4, 5 up 2. So again, y-intercept of 9, going right 1, 2, 3, 4, 5 up 2. Again, they look similar, but this slope is 2 over 5, which in decimal form would be 0.4. This one, a same y-intercept of 10, but I'm going over 1, 2, 3, 4, 5, 6, going up 2. So right 6, up 2. So I have a run of 6 and a rise of 2. If I put that together, that gives me a slope of 2 over 6. And change that from a 5 to a 6. And that gives me a slope of 0.3. So you can see this one has a greater rate of change. It is linear. It is continuous because it's a straight line through it. So make sure, honors kids, write this extra problem to show me. The next word, the fifth word is the fifth word is geometric. Geometric. Okay, last problem is a mega conversion one, but that's okay. I have faith in you, so I'm going to shrink that down. It's this problem right here, where I'm going from miles, 1,000 miles here, going up by 6,000. I'm going up by 1 hour. This one has a slope of 6,000 miles for every 1 hour, or 6,000 miles per hour. The other one, I'm going up 2 for miles and up 1 for my seconds. So that is 2 miles per second. But we're going to do a double conversion to get it to be miles per hour. So 2 miles for every 1 second. Again, doing my conversion there. That gives me 2 miles for every 1 second. I'm going to change that from seconds to minutes first. So again, you need to know there are 60 seconds for every 1 minute. And then one more conversion. 60 minutes for every 1 hour.
So a double conversion going from miles to second to miles per hour. The second units will cancel, the minute units will cancel, and I time straight across, and all I'm left with is the mile unit over the hour unit. So seconds cancel, minutes cancel. 2 times 60 gives me 7,200, I believe. $7,200 miles for every 1 hour. So you can see 2 miles in 1 second is a greater rate of change than 6,000 miles per hour. So that one is the greater rate of change. That is linear. All right, the last word is recursive. Recursive. So good luck, honors kids. Hopefully you check that key in all your work and copy what I did. There were 6 words to write down, and then these 2 extra problems for you to do. Document everything on your slides. Good luck.